Thank you, everyone, for coming. It's an absolute delight to be here, despite the little bit of nerves. I'm going to be talking about, as was mentioned, getting your automated tests in the pipeline. A little bit of this is opinion, but a little bit, or most of it, is actual experience of what we did the last couple of years in the company that I work for. The company I work for is called GlowFox. What we do is provide software solutions and capabilities that allow fitness studios and gyms we give them the capabilities to allow them to run their business. Now, let's be honest, writing a little bit of code that will exercise an application really isn't that hard. Heck, you might not even write it. You could use a record and playback tool. But what can happen over time as you start to add more and more tests is that you can find the tests are slow, they're flaky, you're spending, frankly, ridiculous amounts of time debugging, and the developers finally are losing trust in the results of the tests. The other thing that I think can happen is that people can make the mistake of not focusing on the pipeline from the start. Rather, in an attempt to chase coverage, we'll end up writing more and more tests and writing too many tests too quickly. And when that happens, people can go for the default of trying to get feedback from those tests, which is to run them on a schedule, whether that's during the day or overnight. But either way, if the developers are committing with any kind of cadence, if a test fails in one of those executions, it can be hard to understand, well, which particular commit caused the problem. Further, I think you actually need to make the developers have skin in the game. You need to make developers feel responsible for the outcome of the test results. If there's a failure, they should become responsible for the fix, either a fix to the tests or indeed to the application. And I think that having the tests in the pipeline is obviously a really great way of being able to do that. So when I joined GlowFox a couple of years ago, we were already releasing, on average, 5 times a day. I joined to set up the end-to-end test automation, and I was keen to ensure that while we could add some risk mitigation to this process of release, I was also keen that we wouldn't slow down this cadence. The reason I knew that we were releasing this number of times a day, on average, is that we were tracking our software delivery performance via the 4 key metrics of software delivery performance as popularized by the book Accelerate from a few years ago. These can be considered in terms of, firstly, throughput, where you have the number of releases through the deployment frequency considered, as well as change lead time, and then stability, so where we had hoped to make a positive impact around change failure rate. Why is this important? Well, obviously, we're in the game of releasing value to customers. We want to give them capabilities and features that they want and need. But also by regularly releasing, we're actually going to reduce risk. By continuously integrating, by continuous deploying, by having less barriers between developers making new features and actually releasing them, we can reduce risk. Whenever I've been in the position of setting up some initial end-to-end automated tests for the first time, I've tended to consider any pre-existing manual regression tests as, at best, mildly interesting, at worst, focused on the wrong things, possibly out of date, certainly not written with automation in mind. Further, I think that we can consider any of those pre-existing tests as models of the system, of models of the application. So I think in order to really build effective and good test automation, we need to build our own mental models of how the application works from a user perspective, but also from an architecture perspective. But that modeling, in both cases, can feed into how we decide what are a small set of tests that we could include in a pipeline to start proving out the process, to start building trust. So we can start small with a set of tests that we might, for example, for us, pick something that's related to what are the features that actually make our customers money, what some people call the money path. But we also want to start small because it isn't just about writing enough code to take us from A to B, but how do we write code? How do we think about those models and put those models into abstractions in code that will allow us to write tests not just for now, but for the months and indeed years that lie ahead? So when I joined a couple of years ago, this is, as I said, a simplified pipeline of where we were. We would have a deployment to a feature environment. We would do some acceptance testing. And then after deployment to development, barring any further exploratory regression testing we might do, we would release. But I'd built some of these initial tests focused on the money path. So we got them added into the pipeline. But one of the things I did was not make the test needing to pass. The thing is, if you are at the point of writing end-to-end tests for the first time, you're going to discover behaviors in your application that you have never seen before, that were never possible through what you might call manual testing. Those behaviors need to be worked around or fixed before you can really start having trust in your tests. After a period of time, after, in fact, a number of weeks, whenever I built trust in the tests themselves, that whenever they were failing for the right reasons, we could make the test passing a required step in the pipeline. We want to start adding more tests, of course, but we don't want to wait a few weeks in between adding them each time. So one of the things that we can do is actually test our tests. So in GlowFox, what we have is a single test automation repo that we can then run across multiple pipelines. But we have a basic process that whenever we make a pull request to that automation repo, we can discover the changed code, we can discover the new or changed tests, and run them before we actually add them. Particularly for the browser tests, we can run them in a loop. We choose 10 times to see if it passes every time, then we are probably okay. It doesn't mean to say that you're not going to get an issue when it runs for the 500th time. You may still do so, but there's obviously limits to how much you can run your tests before you add them. And then we wait. And perhaps we have to wait a little bit more. But we find we start to catch issues, important issues that otherwise would have been released. Whether these are issues because of the coverage that you're able to achieve through the automation that's not practical for a human to do, or because you're crossing boundaries that a more developer-facing integration test is not capable of doing. And we're starting to get that trust that, yes, the problem is actually in the application and not in the tests. So we've got these tests where we have trust, they're finding issues. Another key component of having tests in the pipeline is how you keep the test run times short overall. I think a key consideration, and in fact it's a primary consideration, is thinking about how you're going to run your tests in parallel from the start. This may impact which particular language you want to use, but I think that consideration has to override your other wants and desires around perhaps a programming language. We're using WebDriver IO for the browser interactions and Jest for the tests which are purely API in nature, so using that as the test runner. In either case, they can provide that capability to run tests in parallel. If you're using different language, different tools, you may have to build something yourself, and that's not something personally I want to ever have to do again. Of course, it's easy to scale through cloud providers. One thing to note, usually the cloud providers provide their services by allowing you to make requests over HTTP. If you're doing things over HTTP, that is going to introduce latency. Your tests are potentially going to be 3 times as long. That can be mitigated by obviously scaling out, but that can come with cost. What we do personally is we build a Docker image containing our tests, containing the libraries that we require, containing Chrome and Chrome driver. And within that, and we're running on Circle CI, within that, we can spawn local instances of Chrome driver and Chrome to run our tests. And at that point, we're just limited by the CPU. But for example, for Circle CI, a medium CPU or medium virtual device will still allow you to quite easily run 4 tests in parallel on that device. We can then scale out by the numbers of virtual machines. There are different ways to manage this. Some CI tools like Circle CI or libraries like Jest allow you to shard tests. Some even allow you to take historical data to allow you to try to balance the execution time across your shards. What we do, though, is we organize by domain. We have multiple pipelines. So there are some tests that we want to run as part of the payments pipeline, some tests that we want to run as part of the memberships pipeline, and so on. And then we just focus for each of those suites of trying to keep the overall test run time down. But it's not just about the libraries and the frameworks that you're using. Your tests themselves have to be capable of running in parallel. Your tests need to be independent of each other. You cannot have one test depending on another in order to achieve that parallel execution. Ideally, and I know that in Glowfox we may have a slightly ideal situation in that we can actually set up most of our data through API calls that are within the test itself. So rather than having a lot of data that's through a database update, for example, that then different tests are trying to consume, we can manage that data independence within the test. If you do have that consideration where you don't have those APIs and you're setting up data beforehand, you really need to think about how you're going to handle one test consuming data that another test might want to do so as well. Another key aspect is the idea of atomic tests. So this is the idea of, so rather than, whenever people talk about end-to-end tests, they sometimes talk about a journey, a user journey through the application. And that's okay, but really we need to be focusing on what's a small journey that someone might be doing. So for us, that might be booking a member into a class. Of course, there are a number of steps required to be done before you can actually do that, but the focus is on booking a member into the class. And the more that we can keep our tests focused on one thing, the more that will help with the parallel execution, because we are more likely to be keeping an individual test run's time as short as possible, so that there's no single test making the whole suite longer. What we talked about just there was about maintenance, but this part is really about thinking about how we write the tests themselves. How do we write tests that are in, for example, the language of the application and not the language of the tool or the library that you're using? So rather than writing tests that revolve around making the tests themselves having gets or push requests actually written in them, or clicking buttons or entering text, how are we taking the modeling that we talked about before and putting that into designing abstractions around the domain that you're working in? So this is pretty much a test that we have. It's obviously not code, but it is pretty much how you would actually read the test as if it were code. So we can log in, we're adding a member, purchasing a membership for that member, booking the member into the class, and then there's some assertions. But by starting with modeling at the domain level rather than using just the abstractions provided by the tools or the libraries you're using, because we have that API first kind of setup, we can change these steps. So rather than being through the browser, we can make all the setup and the assertions done through the API. This will obviously feed into making the test more stable and quicker as well. Okay, so it's a good time I'd win a bit quick. It's a good thing I'd win a bit quick. So having short tests is important, obviously, from feeding into that idea of keeping your total test run time as part of the pipeline as short as possible. But your tests are much more likely to pass the shorter they are, as indicated by this this report from SOS Labs from a couple of years ago, where they indicate that tests that are 2 minutes or less are nearly twice as likely to complete, or as likely to pass. There is, I think, probably some nuance here. For example, the tests are likely to be longer because of that latency that we talked about before. But I think the principle still applies. Having your tests atomic, focused on one thing, is going to make them more likely to pass. And if they do fail, you're less likely to have to deal with, okay, which step in this whole test actually caused the problem. So this is where we are. Obviously, the number of tests is an absolutely horrendous metric for anything. But hopefully it does give you a sense of where we are, even if this is a little bit disingenuous in that whenever it says browser, all that means is that WebDriver IO actually launched the test. Most of the steps within the browser test are actually API steps. So this is where we are now, a bit over 2 years later. We are releasing on average 10 times a day for the last quarter. And hopefully, as you've seen, we're releasing with a little bit more of that risk mitigation in place. But that's it for me. You can find Twitter handle on my blog, but I think we've got plenty of time for questions.
Yes, we have time for questions, but so far we only have 2. Let's see. Can you throw some light on how you find the impacted tests?
Sure. So we're using GitHub, and with GitHub, what you can do is you can if you do a pull request, you can use the GitHub commands to discover what's the difference between the branch you're on and master or main, whatever's your mainline branch. And from that, they'll give you a list of files. So we use that, and then in combination with a flag that you can pass to Jest, you can find, it's called find related tests, and it will actually show you, well, for any part of your code base, this particular test or set of tests is impacted. And then you can make a decision, okay, which of these tests am I likely to need to run in order to check things are okay? You can run everything every time, but that's obviously going to be time consuming and most of the time not necessary. And we also want to be able to target the browser tests specifically to be able to run them in a loop. I guess that's one of the things I skipped over, is that whenever you run your tests on remotely, you're going to discover issues with latency, with the process constraints on the system, with async operations that are happening that aren't so obvious whenever you're just running a single test locally compared to when you start to really scale that up. So you're looking to discover those problems.
Okay. What approach to take if there are flaky tests that need to be added to the pipeline?
We do that a little. We can do it with our API tests. So we've added a capability that allows us to tag the tests. The principle applies, just the implementation's a bit harder with the browser tests. But the idea is that you can add, it depends on the framework, but there are some tools that allow this, like Playwright, for example. So you can indicate a test as flaky, add it to your repo, and it will automatically invert the result. So if you know the test is failing, but you want to get it into your pipeline, you can use this to invert the result. If it then starts to pass, it will then fail to tell you, hey, this test used to fail, it's now passing, you may need to look at this.
Okay, luckily we already have it on the big screen. Docker reduced the execution time for product tests, but what will be the solution you suggest? I
guess I can only say what's working for us. Cost plays a part. We were already using Circle CI. It was the most, at that point, a couple of years ago, was the most convenient way to get something happening without any further approvals. It worked out. There's a lot of the public services, the cloud service, offer a lot of features that can be real value add, but a lot of it will depend on your budget and your context.
Okay. For people starting their automation journey, any advice about best practices?
Learn how to code. Learn how to code. Give yourself opportunities to write some bad automation. You need to get into a position of learning your mistakes, learning what doesn't work, and a lot of that will provide the foundation to find out something that will work. But a lot of it is focused on writing code. The most success I've had certainly is going back to those domain abstractions. That's where you'll get the value of being able to really scale out your tests. I think people can make the mistake of focusing on the nuances of a particular tool or library, and while that's important and necessary to actually make your test run, it will not allow your test to scale if you focus on that. You need to think about those domain abstractions, and for that, it requires thinking about modeling and how you do that in code.
Okay, how does your testing pyramid currently look like? For example, the percentage of end-to-end system or unit tests?
I have no idea. It's not something I personally worry about. I know the developers are writing good unit and integration tests. We think about what's the most important place to put tests, but we never objectively measure in that way. And then we think about what's just enough tests at the end-to-end level that will provide us the assurance we need. But yeah, sorry to disappoint, I actually don't care.
Okay, just in the last second, another question came in. How do you mitigate the impact of parallelized tests sharing the same resources? Is it sensible to merge test causes in this situation?
Merge test cases, okay. No, I think you need to understand the problem. And a lot of the time, this is going to... the problem with end-to-end tests sometimes is that they can give you a signal of something's wrong, but they aren't always good at telling you what is wrong, particularly whenever you run into constraints around things like async processing or hardware constraints. And that's where really you need the involvement of the developers to understand, okay, I'm seeing something in the test, but what does this actually mean in the application?